Today we will discuss differential equation reducible to homogeneous differential equation. That is, dy upon dx is equal to ax plus by plus c upon a dash x plus b dash y plus c dash. This is the form of a differential equation which is not homogeneous differential equation, obviously, because degree of all the terms are not same. Degree of this term is 1, degree of this term is 1, and degree of this term is 0. Similarly, in the denominator, the degree of first term is 1, degree of second term is 1, but degree of third term is 0. This form of differential equation can be reduced to homogeneous differential form. So, for example, the equation dy upon dx is equal to x plus 2y minus 3 upon 2x plus y minus 3 is the form dy upon dx is equal to x plus by plus c upon a dash x plus b dash y plus c dash, where a, b, c and a dash, b dash, c dash are constants. First, we need to assume x is equal to capital X plus h, let it be equation number 1, and small y is equal to capital Y plus k. We have to make these two substitution in this equation, but accordingly we have to change dy upon dx also. So if we differentiate equation number 1, we get dx is equal to d capital X, and if we differentiate this one, we get dy is equal to d capital Y, because h and k are constants here, and differential of these two terms will be 0. So if we divide this equation by this equation, so we get dy upon dx is equal to d capital Y upon d capital X. If we substitute x is equal to capital X plus h and y is equal to capital Y plus k in this equation, we need to replace dy upon dx also by d capital Y upon d capital X. Here we write d capital Y upon d capital X is equal to x is written now capital X plus h plus 2, y is written now capital Y plus k minus 3 divided by 2 bracket capital X plus h plus capital Y plus k minus 3. Now we have to simplify dy upon d capital X, then we write capital X plus h, open up this bracket, 2 will multiply both the terms, we get 2y plus 2k minus 3 divided by, in denominator, if we open up this bracket, 2 will multiply both the terms, we get 2 capital X plus 2h plus capital Y plus k minus 3 as it is. So capital X is written first, then 2 capital Y. Rest of the terms are written afterwards, plus h plus 2k minus 3 divided by 2 capital X plus Y plus 2h plus k minus 3. Let it be equation number 3. The next step is we have to equate these two expressions to 0 separately. So h plus 2k minus 3 is equal to 0, and 2h plus k minus 3 is equal to 0. Transposing 3 to right hand side, we may write it as h plus 2k is equal to 3, and 2h plus k is equal to 3. Then we solve these two simultaneous equations for h and k by elimination method, or by cross multiplication method, or by substitution method, any method you like. We have to solve for h and k. So I'm going to solve this by elimination method. So in order to do so, we have to multiply this equation by 2. 2h plus 4k is equal to 6. And this equation is written as it is. 2h plus k is equal to 3. Then we subtract 2h, positive negative cancel, 4k minus k, 3k, and is equal to 6 minus 3, 3. So we get k is equal to 1. This value of k is substituted in this equation. So h plus 2, h is plus 2 into 1 is equal to 3, or h is equal to 1. That means transposing 2, we get 3 minus 2, that is 1. So h is equal to 1 and k is equal to 1. These two values we have to substitute in equation number 3 and equation number 1 and 2 to find the exact relation between x and capital X, y and capital Y. So putting the values of h and k in equation 1, 2 and 3. Now proceeding from this step, now we have to put h is equal to 1 in equation number 1 first. So we get x is equal to capital X plus 1. In place of h we have written 1, so x is equal to capital X plus 1, or capital X is equal to small x minus 1. Let it be equation number 4. Now we have to substitute k is equal to 1 in equation number 2. So if we substitute k is equal to 1 here, we get small y is equal to capital Y plus 1, or capital Y is equal to small y minus 1. Let it be equation number 5. Now if we substitute h is equal to 1 and k is equal to 1 in equation number 3, so since we have taken these two expressions equal to 0, so automatically these two expressions will be 0, and we are left with only capital X plus 2 capital Y in the numerator and 2 capital X plus capital Y in denominator. So d capital Y upon d capital X is equal to capital X plus 2 capital Y upon 2 capital X plus capital Y. And now obviously this is a homogeneous differential equation because degree of every term in numerator and denominator is equal to 1. So now we have to proceed according to homogeneous differential equation. So here we have to use capital Y is equal to u capital X. Differentiating this equation with respect to x, we get d capital Y upon d capital X is equal to, on the right hand side we have to apply product rule. So u and differential of capital X with respect to capital X is 1 plus capital X as it is, and differential of u with respect to capital X du upon d capital X. Now we have to replace d capital Y upon d capital X by this expression, and we have to substitute y is equal to u capital X here in this expression. So we get u plus capital X du upon d capital X is equal to capital X as it is plus 2 u capital X upon 2 capital X plus u capital X. Clearly capital X is common in numerator and denominator both, so we have to take x common. We get 1 plus 2u upon capital X 2 plus u. X is cancelled by x, so finally we get u plus capital X du upon d capital X is equal to 1 plus 2u upon 2 plus u. Now we have to transpose this u to right hand side. We get x du upon d capital X is equal to 1 plus 2u upon 2 plus u minus u. Now taking LCM, 2 plus u, we get in the numerator 1 plus 2u minus u multiplied by 2 plus u. So x du upon dx is equal to 1 plus 2u. Opening this bracket, we get minus 2u minus u square. Minus 2u minus u square divided by 2 plus u. 2u positive and 2u negative are cancelled with each other. So capital X du upon d capital X is equal to, here 1 minus u square is left, in denominator 2 plus u is left. So taking minus common, we get u square minus 1 upon u plus 2, because addition is commutative, so 2 plus u may be written as u plus 2. Now we have to transpose this expression, leaving minus sign here, to left hand side, and x dx to right hand side. We get u plus 2 upon u square minus 1 du is equal to 1 upon capital X dx. Now it is variable separable form, so next step we have to integrate them. We get integral u plus 2 upon u square minus 1 du is equal to integral 1 upon capital X, d capital X. Now we may split it up as integral u upon u square minus 1 du plus integral 2 upon u square minus 1 du is equal to integral 1 upon capital X d capital X. Now multiplying and dividing by 2. So we write half outside and we multiplied numerator by 2, and we are doing so because differential coefficient of u square minus 1 is exactly 2u. So to make exact differential of denominator, we have written half outside and 2 in the numerator. This 2 is constant coefficient, should be taken out. 1 upon u square minus 1 du is equal to integral 1 upon capital X d capital X. Here by mistake we had left minus sign. So now proceeding from this step, obviously the differential coefficient of u square minus 1 is 2u. So if we substitute u square minus 1 as t, then differentiating we get 2u du is equal to dt. So we may replace 2u du by dt and u square minus 1 by t. So we get simply integral 1 upon t dt. So that will be log t, and afterwards we have to substitute the value of t, u square minus 1. So directly we may write it as half log u square minus 1 plus 2. Now the next integral is the exact form of 1 upon x square minus a square, whose integral is 1 upon 2a log x minus a upon x plus a. So here a is 1, so 1 upon 2a will be 1 upon 2, and log u minus 1 upon u plus 1. On the right hand side, minus integral of 1 upon x dx will be log capital X, and plus constant of integration should be taken as log c, because all the terms are in the logarithmic form, so it is better to take constant term as log c. Now this is cancelled. Now if we multiply the whole equation by 2 to eliminate this half, we may write it as log u square minus 1 plus, here will be 2 now, after multiplying by 2 the whole equation, 2 log u minus 1 upon u plus 1 is equal to minus 2 log capital X plus 2 log C. Now log u square minus 1 plus, by the property of logarithm, the coefficient goes in the power of the expression in the mantissa. So u minus 1 upon u plus 1 whole square is equal to minus, this 2 should also be taken in the power of x square, and this 2 also in the power of c, so log c square. Now log u square minus 1 plus log u minus 1 whole square upon u plus 1 whole square is equal to, now it is better to transpose log x square to left hand side, so it becomes positive over there. Log capital X square on the right hand side, only log c square is left. Now log m plus log n is equal to log m into n, so applying that formula, we may write this expression as log u square minus 1 multiplied by u minus 1 whole square upon u plus 1 whole square into and log c square as it is. From both sides we may eliminate log now, so this may be written as u plus 1 into u minus 1, here u minus 1 whole square upon u plus 1 whole square, and capital X square as it is equal to c square. So x plus 1 bracket will cancel 1 power of u plus 1 from the denominator, and we get u minus 1 and u minus 1 whole square in the numerator, so we get u minus 1 whole cube upon u plus 1 capital X square is equal to c square. Now we have to write down u as capital Y upon capital X. From this substitution, the value of u is capital Y upon capital X, so we have to write here capital Y upon capital X minus 1 whole cube upon capital Y upon capital X plus 1 capital X square is equal to c square. Into capital X square is equal to c square. Obviously this x will cancel 1 power of capital X from here in the numerator, and finally this x square will cancel this x square, so we get only y minus x whole cube upon capital Y plus capital X is equal to c square. Now finally we have to substitute the value of capital X and capital Y from equation number 4 and 5 in terms of a small x and a small y, because our final solution should be given in the same variable as given in the sum. So from 4 and 5, from equation 4 and 5, capital X is equal to small x minus 1 and capital Y is equal to small y minus 1. Putting these two values in this expression, we get y minus 1 minus x plus 1 whole cube, because if we substitute here x minus 1, because of this minus, both sign will be changed, so we get minus x plus 1 divided by y minus 1 plus x minus 1 is equal to c square. In the numerator, minus 1 plus 1 are cancelled, and we are left with a y minus x whole cube upon, in denominator, y plus x minus 2, minus 1 and minus 1 is equal to c square. So this is the required solution of the given differential equation, or you may write it as y minus x whole cube is equal to c square y plus x minus 2. So this is how we find the solution of a differential equation given in the form dy upon dx is equal to ax plus by plus c upon a dash x plus b dash y plus c dash, which is said to be a differential equation reducible to homogeneous differential equation.